let's dive into one of Java's most useful tools, the set interface. We're going to talk about its special superpower, which is guaranteeing that every single thing in a collection is absolutely unique. So think about this for a second. You're building something. Maybe you're tracking unique user IDs, or you're cataloging parts in an inventory. What do you do when you need a collection that just flat out refuses to accept any duplicates? Because, in a lot of real-world apps, letting a duplicate sneak in isn't just a minor bug. It can totally break your logic. So in this explainer, we're going to get right into how Java's set interface solves this exact problem. Now, to really appreciate why sets are so great, let's first take a look at the problem. And that starts with a data structure we've all used a million times, the good old list. Okay, so here we have a totally standard array list. We add the number 10, no problem. We add 20, still good. And then we add 10 again. Does the array list care? Not one bit. It happily stores both of them, and you end up with a list that looks like this: 10, 20, 10. For a list, duplicates are just part of the deal. But what if that's not what you want? Well, this is where the hero of our story makes its entrance. Let's talk about the set interface. The definition really says it all. A set is, plain and simple, a collection that cannot contain duplicate elements. Its entire reason for existing is to enforce uniqueness.
All right, let's run that same little experiment. But this time, we'll use a hash set. We add 10, we add 20, and now we try to add 10 for a second time. And what happens? Absolutely nothing. The second add 10 is just ignored. The set basically looks at it, says, hey, I've already got one of those, and just moves on. The final result? A collection with just 10 and 20. That's it. Problem solved.
Okay, this is pretty cool, right? But as you know, every decision in programming comes with a trade-off. So if a set is busy making sure there are no duplicates, how does it organize everything? Can you, for instance, just ask for the element at index 0? And the answer to that is a hard no. You cannot use an index like getArea0 to pull an element out of a set. The whole concept of a position, first, second, third, it just doesn't apply to most sets the way it does to a list. And this right here perfectly illustrates that core trade-off. With a list, you get that nice, predictable, index-based order, but duplicates? Yeah, that's your problem to manage. With a set, you get automatic uniqueness. It's handled for you, but you have to give up that direct index access. You gain one thing, you let go of another. So let's just quickly lock in these fundamental properties. A set only stores unique elements, which means no duplicates allowed. It doesn't support indexing. And here's a fun little detail. Most common implementations, like HashSet, will let you store one and only one null value. Now for my favorite part, how does a HashSet pull off this magic trick so fast? Well, the secret is that it's actually getting a little help from another famous data structure behind the scenes. It's actually being powered by a HashMap. This is such a clever implementation. When you add an element to a hash set, what's really happening is that your element is being used as a key in a hidden hash map. And the value, it doesn't even matter. It's just a dummy placeholder. And since HashMap keys have to be unique, the hash set gets that uniqueness property for free. Okay, so here's a crucial point. Not all sets are built the same. The Java Collections framework gives us a few different versions, and picking the right one for your specific job is, well, key. We're going to focus on the big three here. First up, you've got HashSet, which is your go-to when you just need raw, unadulterated speed. Second, LinkedHashSet, which is for when you need to remember the exact order you added things in. And third, TreeSet, which is for when you need your elements to always be in a sorted order. This table really breaks it all down. HashSet is unordered, but it's the fastest. We're talking constant time or O of 1 for most operations. LinkedHashSet is almost as fast, but it maintains that insertion order. TreeSet is a little bit slower, log time or O of log n, because it's doing the constant work of keeping everything sorted. And notice this, TreeSet does not allow null elements. So your choice really comes down to what you need: pure speed, insertion order, or sorted order. All right, let's wrap this all up, and then I've got a little challenge to help you put this into practice. So when should you reach for a set in your code? Well, use it anytime you absolutely must guarantee uniqueness. Use it when you need to do really fast lookups to check if an item already exists. And it's also perfect when you're modeling mathematical sets and doing things like unions or intersections. If you only remember one thing today, let it be this: A set is your guarantee for data uniqueness. It is the right tool for the job whenever duplicates are simply not an option.
And now it is your turn. I've got a little micro challenge for you. Pause this explainer, open up your favorite Java editor, and just create a hash set. Try to add a few items, including some duplicates, and then just print the result to the console. See with your own eyes how it handles them.
So we've covered what a set is and which one to pick, but we also hinted at that magic behind its incredible speed, that internal HashMap. Now that you know what a set does, aren't you just a little bit curious how hashing makes it all happen so incredibly fast? Well, that's exactly what we're going to break down in our next explainer.